How many of you have seen this formula before? And have you gotten to it in your science class yet? Hand or two up. Everybody will. We call it the combined gas law. Sometimes it's also called the ideal gas law. So if you have the same kind of gas, but you change the conditions of it, that's when this gas law applies. So maybe you've got two different samples of it. And so for the first sample, you have one amount, so one volume, and it's under a certain pressure and at a certain temperature. And maybe in a different room or on another day, or you have a second sample, but still the same kind of gas. And if the pressure then is different in the volume and the temperature, this ratio, this relationship will always be true, that the pressure of one times its volume divided by its temperature will be the same as the pressure of the other one times that volume divided by that temperature. Sometimes we get to make the formula even shorter if one of the variables stays constant. So let's suppose we keep the volume the same in both. So if V1 and V2 are equal to each other, I wouldn't really need the subscripts. I could just call them both V because they're the same. And then I could divide both sides by that V, and I'd really only have P1 over T1 is P2 over T2 if the volume is constant. I could keep the pressure constant, and then if P1 and P2 are the same as each other, I wouldn't need the subscripts. They could both be P. Divide both sides by P. And all I really have to worry about in the formula now is V1 over T1 equals V2 over T2. Because the pressure is constant, I don't even need to worry about putting pressures in the formula. Same thing, if the temperatures were the same, I wouldn't need the subscripts. T1 and T2 are the same, so I'll just call them both T. Multiply both sides by T, and the T's cancel. And the only part of the formula I have left would be P1 V1 equals P2 V2. Now, only memorize this main one. Just know that if you know one of those is constant, you can skip writing it down when you write down the formula. Does that much make sense? Okay, let's try two examples, and that's all we're doing today. So we have some kind of a gas, and we know we have 8 liters of it, and that the temperature is 1,000 kelvins, and the pressure is 200 newtons per square meter. And then we have a second sample of it, and this time the volume is 10 liters, the temperature is 800 kelvins, and we want the new pressure. And I'm going to model two ways of setting this up and solving it. They are equivalent, but I'll also talk about how sometimes one way might make more sense than the other way. So first thing is going to be always write down the basic formula. P1 V1 over T1 equals P2 V2 over T2. One way to set it up would be to substitute in the information I've just read in the problem. So 8 liters, that's my first volume. My temperature, 1,000 kelvins, that goes where I have the first temperature in the formula. And the pressure for that first one is 200 newtons per square meter, so I put the 200 where I had the P1. Then I'm going to plug in what I know for case 2. I know that the volume is now 10 instead of 8. And I know that the temperature is now 800, so I put that where temperature goes for case 2. And I need to find P2. So I've only got one variable in there. I want P2 equals. I don't want 10 over 800 times P2. I just want one P2. So to solve that, I could simply say, if I want just a 1 P2, I need to multiply both sides by the reciprocal of what I see right there. If I multiply by 800 over 10, will I just have P2? 1 P2 instead? So I will then have that P2 is 200 times 8 times 800 over 1,000 times 10. I think I got all of that in there correctly. And then if you, ladies and gentlemen, would please punch that in on your calculators and tell me what you get. Simply do control divided by and put all of your numerator numbers in and denominator numbers in, and what do you get? And yes, on one like this, it would be okay to cancel some zeros if you wanted to, but an awful lot of the problems that you have won't have nice numbers with all those zeros. You'll have things like 713, and there's nothing that cancels easily with that one in there. So I wanted to model, just punch the whole thing in. So how many of you have an answer already on your calculators for me? Yo-Yo, what do you have? Anybody else? 128? So that means that our second pressure would be 128, but we need some units. And I'm not real familiar with all of these. Some of you scientists, maybe I got to look back and read. What are my units for pressure? Pressure is newtons per square meter. So that's how I label this thing. Newtons per square meter. So any questions on that way of solving it? Evelyn? You can, but that's actually one extra step in there when you do that. If you cross multiply, you're going to have 200 times 8 times 800 equals P2 times 10 times 1,000, and you're still going to have to divide by the 10 and by the 1,000 to get what you're looking for. So it's more writing if you write it down with the cross multiplication, and less writing if you think of, oh, let's just write down multiplying both sides by the reciprocal. The second way to do this would be get a formula for the part that you're trying to find. We're trying to find P2, so we could first get a formula for P2 before we put any numbers in there. So we go back to our basic formula here, and we want to get P2 by itself. Same idea. I don't want P2 by that fraction, so I am going to multiply both sides by the reciprocal of the fraction that I see here, so by T2 over V2, and then I have P2 on the right, but I'm now going to write it first, equals P1 V1 T2 over T1 V2. And if I plug all of those numbers in, I get exactly the same thing. Reasons you would want to do the formula first. The book or the test says, first find a formula for P2. Or your science teacher says, what is the formula for P2? Or your science experiment says, change the temperature and the volume to this, what happens? Then change the temperature and the volume to that, and what's going to happen to the pressure? And then change the temperature and the volume to something else, and what will happen to the pressure? And then change the temperature and the volume to something else, and what will happen to the pressure? Instead of redeveloping that over and over that many times of multiplying by the reciprocal, do it once with the formula, and then you're just plugging in each time, and it's more efficient. Questions on that from anybody? On either method of approaching it? And you understand the difference, read it carefully. If it asks for a formula, you got to do this first. Okay, one last example for the day. So we're talking about our combined gas laws, P1 V1 over T1 equals P2 V2 over T2. The temperature is held constant at 1400 kelvins. Well, I could put 1400 in for both of the T's, or that observation we had, if the temperature is constant, I don't even need the T's in my formula. So I don't even need to write that down. I can just write down P1 V1 equals P2 V2, and then finish solving from there. So now I know the original pressure was 11. The original volume was 44. And the volume is reduced to 4.4. What is P2? What do I need to divide both sides by? Elias, what do I need to divide by? 4.4, and let's not use a calculator on this one. 4.4 times how many equals 44? If I take 4.4, what do I need to multiply it by to get 44? Kylie? 10. So that means that's a 10, and 10 times 11, P2 is 110, and label our units atmospheres. And that would be all that we would really need to do on that one. If we did this one the other way, final pressure, if we wanted a formula, would be P1 V1 over V2. We'd plug in the 11 and the 44 and the 4.4. Oh, that's identical to what we were evaluating here. We would still get 110 atmospheres. Thumbs up, thumbs down. How do you feel about this particular lesson? All right, we will get started on homework then.